Yes, okay. Vielen Dank für die Introduktion. Ich spreche ein bisschen Deutsch, wie ich niederländisch bin, originally. Also mein Deutsch ist nicht super gut. Ich verstehe es ein bisschen, wenn Sie Fragen hatten und das in Deutsch fragen wollen, dann verstehe ich das. Aber ich glaube, dass es besser ist, wenn ich die Präsentation in Englisch gebe. Ich hoffe, dass das okay ist für Sie und meine Entschuldigung für mein Deutsch.
Wir verstehen dich sehr gut.
Okay, good. I have a presentation. Let me share my screen, and I hope also I will show some things through the camera, specifically, for example, the glasses that we use. And we are not gonna chase Pokemon, but it's exactly that. Augmented reality allows you to show virtual data projected into the real world around you. And so either whether you can play games like Pokemon Go, but you can also use it for industrial applications such as showing underground grids and other data, geospatial data that might be useful for your company. So let me start off. I will share my screen. I will give a quick introduction about myself as well, so you know who I am. I hope everybody can see my screen. Ben,
looks good.
Is it okay for you, Ben? Can you see the screen?
I can see the screen, yes.
Okay.
Thanks.
Okay, perfect. Okay, so first of all, quick introduction. No, I wanted to thank you first of all for coming. I saw there are a lot of people in this call. I really appreciate that you're taking the time to join the InfraLab, to see what we're doing and to listen to my presentation. A little bit about myself. So I grew up in the Netherlands. I'm a physics engineer from Delft University of Technology. I worked for about 10 years in the utility industry. For example, at Stedin, maybe familiar to you. Stedin is a large utility in the Netherlands covering the gas and electricity distribution. It's a DSO in Rotterdam, Utrecht, and Den Haag. After which I moved to Switzerland. Ich wohne heute in Genf. Also ich spreche hauptsächlich Französisch hier. Geneva is French. It's a French part of Switzerland, so I speak French here instead of German. And so also in Switzerland, I worked for a couple of years in utility industry, for example, in Group E in Freiburg and Romande Energie in Canton Waadt, Vaud in French. So that's my background. Coming from the utility industry, we came up basically with showing or using augmented reality for showing the underground grids, and I'll explain to you why in the next coming slide. So I will start off with my presentation, augmented reality for geospatial data. Let me quickly do. Oh. So this is better, I think. So augmented reality for geospatial data. So what we've developed is an augmented reality solution for surveying, construction, and maintenance work. And what you can see here in the middle is the glasses that we use. So we use specifically glasses instead of the tablets and smartphones that you might already have seen. Why have we developed an augmented reality solution for geospatial data? Well, as I explained before, I come from the utility industry, and before construction works take place, a surveyor usually has to go out in the field to spray the location of the underground grids on the street, right? So that during construction works, they avoid hitting underground cables. So here you see the surveyor with a GPS and a 2D map, measure, spray, etc. And this work is not only very time consuming, it's also prone to human errors, and these errors often lead or sometimes lead to damages to underground grids. And so I used to be a risk analyst at the utility industry, and I worked in strategic asset management for investments and budget management and things like that. And one of the issues that utilities in the Netherlands as well as in Switzerland run into is that about 30% of the power failures are caused by excavation works. So, and that is partly due to human errors, partly due to data problems, data quality, etc. So with that in mind, we thought, okay, can we not improve that? Can we not do something to help utilities, but also construction companies to avoid damages, but also increase the efficiency of their work? So that led us to developing a augmented reality solution. Here you see an image taken through the glasses. So we developed an augmented reality solution for augmented reality glasses, very specifically. And we integrated these glasses with a GNSS RTK technology, which is, if you don't know what that is basically a very accurate type of GPS, which is used by surveyors. Now, and this GNSS RTK technology allows us to visualize geospatial data with centimeter accuracy in the field. So, so here you see, just to give you a quick idea of what it can look like, this is already from 2-3 years ago, a pilot we've done with a utility in Switzerland. And here we compare our work or our solution with their original equipment. And you can see here the surveyor with his GPS technology from Leica, and his map, etc. And so he's measuring points and so we basically compared his work with our solution. And here you see the old version of the HoloLens, the HoloLens 1. And voila, here you can see, for example, what you would see through the HoloLens. And you can imagine that by seeing the underground grid where everything is located, that can strongly increase the efficiency of the work. Now, moreover, you have your hands-free. So apart from just visualizing data, you have your hands-free to do other tasks. So you don't have, when you have a smartphone in your hand, you have to put it down. So we decided to really go for this, these glasses. So this gives you an idea of visualizing underground grids. Now, from the pilots we've done with utilities, we've noticed an increase in efficiency of about 25 to 50%, depending on the complexity of the situation. So if there are a lot of cables underground, it becomes more complex. So there you have a larger efficiency increase. Whereas if there is just one cable, the efficiency increase is not as much as when it's very complex. So we have a high efficiency increase. You avoid human errors. You can also verify engineering plans in the field. So you can imagine if you want to do place a new grid, you have made your design, but you can verify that in the street in real time to make sure if there are no trees in the way, other obstacles, things like that. So you can verify engineering plans before construction. Our solution is really simple to use, so you can put it on, the headset does the calibration itself, so there's not much training needed or education needed for the use of our solution. So you can, so also people that are not necessarily educated in the specific field of surveying, they could potentially use this solution in the field directly. Now, what's very important to mention is that these glasses, they come with a lot of sensors. You see them also here. I don't know, I hope you can still see me. But here you see cameras, depth cameras, time of flight sensors, etc. So they come with a lot of sensors. And since we integrated that with a GNSS RTK system, so this accurate GPS, we can not just visualize information, but also measure objects in the field. So just by simply looking at objects in the field, we can measure their coordinate, their GPS coordinate, with a very high accuracy. So what we're doing currently with the Deutsche Bahn in Berlin, and that's actually why I got in contact with InfraLab Berlin as well. So what we're trying to do with Deutsche Bahn is they are currently installing for the European train control system thousands of these yellow beacons called Balise in German, if I'm correct. And so what we're doing with these glasses, we show to the operator where they need to install them. Then we help them through augmented reality through a sort of a guided installation procedure. And at the end of the installation, we can measure the accurate coordinate of this object. And all that is done digitally through the glasses, so we can then send it back through an internet connection to the office, speeding up also the work and the efficiency and the digitalization of this type of work. I have a few slides later on in the presentation to give you an idea what this type of use case looks like. So what we can do with these glasses is we can do accurate data acquisition of new assets. We can also correct and modify the data of existing assets, add metadata. We can digitize and acquire operational data of, for example, these installation procedures. And we also add photos and videos currently, depending on what the client wants. But for Deutsche Bahn, we take geolocated photos of these objects so that they know exactly where everything is located, what the status, the quality of the installation was, the status or the state of the objects, etc. Now, what makes our solution really unique is and really changes us from our competition is we added this GNSS RTK system. Why do we do that? I hope again you can see me through the glass through the camera. I cannot see you right now, but you can imagine if you put these glasses on, these glasses position themselves through computer vision outside. So that means that if you show data outside through these glasses, they're transparent. I can look through them. If you show data through these glasses outside and you start walking around, this data starts to or tends to start drifting, so it moves a little bit because the computer vision that is used by these glasses to keep the data in place is not perfect. Which means that if you walk around a lot with these glasses, you can have quite a large drift of data and you lose all the accuracy that you need for your work. So for example, over 10 meters walking, you can have, depending on the situation and whether there's a lot of contrast and objects, but you can have like 1 meter of accuracy loss. And that is obviously that renders the application useless. So a lot of our competitors are making a nice augmented reality solution, which looks nice, but it's not very useful if you want to use if you want to do high precision work like surveying. So by integrating this GNSS RTK, we can correct on the fly, real time for this error and keep the data and in place and always show an accurate type of, always show the data with a high accuracy, but also measure with a high accuracy. So that's really what makes our solution different from others. So some use cases where we used it for, this is from EVDS Waterbedrijf, which is the Wasserbetriebe in Rotterdam, in the Netherlands. So this is the use case for Roman Energie, which I just showed you. This is from an engineering firm that uses in Zurich that uses BIM data. So BIM data is a 3D format. We can not just show underground grids, but we can also show 3D buildings, any type of 3D data you might like to show outside in the field. So this is an engineering firm, Basler and Hoffmann, and they use it a lot for construction work. So for them, 3D information is more important. And this is the use case for Deutsche Bahn we're currently working on. We target mainly utilities, construction, engineering firms, and railways. But you can also imagine it for other types of use cases such as tourism, maintenance of green spaces. And we're also looking into, currently not implemented, but we're looking into, for example, connecting it with IoT sensors, allowing us to stream data from, for example, oil sites. You can stream data to the glasses and give information to the user directly from different sensors in the field. So, but this just to give you an idea of what you could do with these type of glasses. Now this is the use case for DB. I would like to give it a little bit of attention. Still have a few minutes, I think. So just to give you also an idea of what you could do as well, apart from just visualizing GIS data of underground grids and measuring, but you can also use it to guide users through this installation procedure. And what we're doing here is for the Alpine, the Rhine Alpine corridor. All these parts of the railways, they need to be equipped with this ETCS, this European Train Control System beacons. And so we help Deutsche Bahn to install these. And what they currently do is I will go quickly through it, but somebody has to go to the field and install it. They get a paper table and they have to locate it with a measuring wheel. They have to verify the ID, etc., and then install it. And then what's very expensive is that a second person has to come to the field to verify the installation, to make sure that the installation was done correctly. If you use augmented reality, we can digitize this whole process and we can avoid having to send the second person to the field. So you save a lot of, basically a lot of money. And so you reduce the installation cost, the operational cost, not necessarily the investment, but the operational cost of the installation by 50%. And how do we do that? We locate where they need to install this balise through geodata. We can automatically verify the ID. We guide the user through augmented reality how to install it, and then we record, for example, the bolting information through an electronic torque wrench. So we're connected with Bluetooth, and we can measure the exact torque that was used to install this beacon, and then we output a report so that the Abnahmeprüfer, they call it, doesn't have to come to the field to verify the installation. So this is what so here you see a quick sample.
Daimler, you just muted yourself, sorry.
How did that happen? I don't know how that happened.
But you're back.
Okay, you heard until when, if I may ask?
The last 30 seconds maybe, and now there's a gray screen in front of your presentation. Here we go.
You see it now?
Yep.
Did you hear
start, yeah.
Okay. I hope. Well, I think I was here, right? Approximately.
Yeah, you can go one more slide, I guess.
Okay. Okay, good. I don't know what happened. Sorry if I muted myself accidentally. So anyways, for Deutsche Bahn, what we're trying to do is avoid having to send a second person to the field to verify or check how the installation was done by an operator, and that saves them a lot of money. To give you an idea of how we do that is we can show to the user where they need to install it, automatically verify IDs, guide them through the installation procedure. And since we have Bluetooth capabilities, we connect the glasses to a electronic torque wrench. I have it here, give you an idea. And so we can measure automatically the torque and save that in the glasses. And then we output a report so that the Abnahmeprüfer, they use that in I don't know if you use the same terms in your industry, but Deutsche Bahn has Abnahmeprüfer. They check, they verify whether the installation was done correctly. So they don't have to come to the field anymore, and it saves them a lot of time. So here you see an example of the user interface that we developed for Deutsche Bahn. I just wanted to give you this use case as well as an idea. Since it's an innovation lab, I thought it might be interesting for you to understand that also other options potential options are useful for your industry or for your company. So we're a small team still. We're currently looking for a developer to grow the team. We're based in Geneva. We are supported by the Innosuisse, the innovation agency from Switzerland, the Federal Innovation Agency. We're partners with Esri, a large GIS software supplier, working with multiple customers, including the Swiss Bureau for Topography, Swiss Topo. And we're also proud to announce that we recently won the European GNSS Agency Award. For the innovation we do with augmented reality. This brings me basically to my final slide. 1 minute left, I think. So what we do in summary, we can visualize geospatial data, we can measure geospatial data, and we can add geo guidance, user guidance through AR. And so all of these together, I can imagine that can create value for the partners from InfraLab, especially for the utilities. We believe that this could be a very useful solution for your industry. So it was I look forward to the discussions and the questions you might have regarding our technology and our product. Thank you very much.
Thank you very much, Thema. Nice presentation. I guess we are a bit smarter now about augmented reality in general. Nice, thank you. Are there any questions directly to Thema from the audience? We have a lot of people here now. I guess a lot of them are not directly from the InfraLab because it's an open event, so everybody can join. Yeah, but if there are any questions, feel free to go ahead. So maybe I start. So Thema, you showed us the HoloLens, right? So do you develop your own glasses, or do you use existing solutions for your glasses?
Yeah, so we really use. I'll show it again. So we really use off-the-shelf products because so this is the Microsoft HoloLens. You know, this is basically, well, there are multiple glasses in the field. The market right now, but the only one that is currently really useful, especially for our type of work, is the Microsoft HoloLens. And this is added to the hardhead by Trimble. So we work with large companies, products that are really well developed and sturdy.
Yeah, makes sense, I guess. Yeah. So and you also showed us some in the video some examples of infrastructure in the ground. And as the InfraLab is all about infrastructure, I would like to know how do you get this data that shows you where, for example, pipes are lying in the ground? Do you approach the companies you're working for and ask them for the data, or do you find it out yourself?
So there are different ways. For example, usually the utilities, they have their own data. So if a utility wants to, usually when a utility goes out, for example, Oman Energy, when they want to use these glasses outside, they just load the data on the glasses, and then they go outside and show the data where they want to see it. Now, so we support DXF file formats, we support KML file formats, but we're also connected through web map services and feature services through Esri. You might be if you're working with the geospatial data in the utility industry, you might know Esri, ArcGIS. Those are very well-known software solutions. So we can connect directly to those databases. And another option is, for example, in the Netherlands, the Kadaster, the National Kadaster, also has, it's called ClickWin. You can sort of download data directly from all the utilities in a certain area, and that currently is not implemented, but those are things we can easily implement, especially since we're connected to the internet. So I hope that gives a bit of an answer to your question, but usually it's the clients that provide the data.
Thanks. And you also mentioned that you can use tools and connect them to the glasses. So if I understood correctly, so that means that if I if I use the tool, the glasses register how much I turned it, and then they can show me like maybe a progress bar showing how much I need to screw again, right?
Exactly. So yeah, so for Deutsche Bahn we're using these HZ tools. It's an electronic torque wrench with Bluetooth, and so we just register the torque. You know, right? If you have a maximum torque you can use for bolting something, we can register how in the glasses through Bluetooth how strong it was tightened. This can be useful for example, for this installation of these balises, but also for other installation where you have a maximum and a minimum torque you would like to use. You could connect to other tools. It's just through Bluetooth connection, so it's rather we can extend that to other tools if needed.
Thanks. So, and if you look in the future of augmented reality, what do you think will happen? Do we see more of that? Do we see like getting into a broader field, getting it into our everyday lives, or do you think it's a special case for companies only use?
Well, we think that, okay, the way we see it is currently you already have augmented reality on these smartphones, and that seems to be at this point still a little bit a gadget type of thing. It's nice and it helps, it's nice, but it's very useful. We're not sure of. What we believe is that in the future, as these glasses become lighter, cheaper, and more easy to use, we believe that there's a huge added value to companies, especially because you have your hands free. You can guide people, so you don't have to have very specialized people for certain tasks. Right, you can send anybody to maintain a machine. Right, I'm talking about the future. Without having the knowledge, you can just guide the user through a process. And so we believe that really in the future people will start using these augmented reality glasses, but especially for the B2B business. I don't see personally yet for consumers. People walking in the street with augmented reality glasses. I'm not sure, maybe, but in the B2B, it's very useful and can gain a lot of efficiency.
So I'm looking forward to a future where I can repair my car myself by having just some glasses, some internet connection, and some tools at my hand, and then it shows me what to do. Exactly. But we have a mention from the audience. We have Regina. She got her hand up. So. Regina?
Yeah, hello, Regina Knirsch from the Berliner Wasserbetriebe. Very nice lecture. I think you made up the point that it's very important to have the accuracy and that you are better than the concurrent situation. But what I would like to ask is, if you wear these glasses when they played the game, you had reports from accidents where they just walked into some ditches or got dizzy by walking with the glass. So do you have somebody to guide the person wearing the glasses? So if they wear it for a longer period, how is the feeling? I know my son can have this three-dimensional look much longer than I can. So can you say something to the experience of the workers in the field?
Yeah. So there. Thank you very much. It's a very good question, Regina. I think there's to answer your question, there are two different technologies. You have virtual reality, and I think that's what you're talking about, where you wear glasses that are completely shut off and you're in a sort of a virtual environment. We also, a long time ago, we developed some virtual reality projects for architects, and that allows you to walk through a virtual building in a virtual environment. I don't have an example here with me, but that makes you very dizzy if the world starts turning. So we had a joystick, so you could sort of move around in a virtual environment while wearing these glasses. And if the world turns and you're sitting still with these glasses on, that made us very nauseated and dizzy. So that was very unpleasant. However, what makes it very different with these glasses is that they're completely transparent. I'll give you an example. Also, if I put them on like this, which may be a bit weird, but at least it gives a good idea. I can exactly see, so I can see the screen, I can see my hands, I can see around me. It doesn't make me nauseated. And so far from the experience we've had with everybody, with the workers wearing these glasses, none of them had a feeling of dizziness or nauseation, how do you say that? Nauseated feeling after wearing it. Now, I don't know if that the example you gave, if that answers your question, but so far we haven't had any bad experiences with being dizzy or not seeing the ditch in front of you, for example.
Yeah, that's perfect. That's exactly what I want to know. And do you have experience when you say you also do building in the BIM process? Do you have experience with the signal within buildings, or if you'd go into a bit under earth, is it stronger, the signal, or is that not appropriate?
That is also very good. So we work with our solution really, our technology really works with integrated GPS. So we need to have some sort of view on the sky so that we have the satellite connection and to get a certain accuracy. Once you move under a building or inside, you lose this connection with satellites, and that means that you can lose accuracy of the data that you visualize. So it's possible to go inside a building, but we cannot guarantee an accuracy anymore that is needed for certain types of jobs. So basically we focus on work outside.
Thanks, very good.
Thank you for your questions, Regina. Very good, thanks.
So there was another question in my mind regarding the battery lifetime. So if you have like this portable device and you go outside, you like maybe if you work with Deutsche Bahn, they're like the rails, you know, and there's like maybe like for 50 kilometers nothing to charge your batteries. So how long can you work with your glasses?
So the battery life of these glasses are currently about 2 hours, 2.5 hours. So that's not so long. You can imagine that somebody has to work with it at least a day, right? The battery life needs to be a day. So what we have, so here you see a USB port. I don't know, you can see it, but you can. So we connect it to an external battery pack that you can put in the pocket. From my experience, the workers they're okay with that because they're used to wearing some things, carrying around some things, so it doesn't bother them. So we can extend the battery life to about a day or longer, depending on the size of the battery pack.
Thanks. Are there maybe in the audience people who already have experience with augmented reality? Is there something you can share? Maybe do you use it in your work life? Is there any application you use? Is there anything?
Hi, it's Andre from Vattenfall Wärme. Good morning, everybody, and thanks for the interesting presentation. Just to answer your question, Ben, we have a kind of little nice application for our heating customers. So we have a kind of app feature on the tablet where we can enter the basement of the apartment buildings, especially in new build or new constructed areas, where we can display for our customers the technical installations for the heating connection. So it's basically an empty room, and then you can just measure the dimension of the room, and then you can display the heating devices to connect the building. And you can also add some like the temperature flows and the heating, the hot water stream and the cold or the return stream to give the customer a better understanding what kind of space he needs for these technical devices and also where the pipes are located and things like this. It's not, I mean, it's not a kind of, let's say, something you can earn money with, but in the end, it's a kind of nice feature also to show our customers that we are engaged and taking these new technologies serious. It's a quite nice little application, I must say.
Nice, thank you, Andre. Is there anybody else having experiences with augmented reality in this group? If not, Daima, maybe you had in your presentation there was some more use cases you teasered us on, but you didn't show us. Like we have seen the one example with the guy and the things on the ground, but we haven't seen. I think there were 2 more videos or something. Maybe you can show us them to see a little bit more of VLabs in action.
Yeah, I saw somebody.
There's also. Oh, sorry.
I think 2 people.
Yeah, sorry, I haven't seen them. So please go ahead. Panos first.
Yes, can you hear me?
Yeah.
Yes.
So I formerly worked in Aachen. It's in West Germany, near the border to the Netherlands.
Near Limburg, right?
Yes, exactly. So there we had a cave installation in the University of Aachen, where we could visualize the project, the models on the walls of the room. So the cave is a space, an enclosed space, which on all sides has projected models. So you can wear the HoloLenses, the old ones, the HoloLens ones. You could walk through the model in this cave, and we use it for class detection and to visualize the models, the different models. Yeah. And this helped us through the planning process, especially for people that are not engineers and they cannot understand the 3-dimensional models. So they could visualize it. You could walk through the model, and you needn't wait to go outside to build something. So we use it's mixed reality. It's virtual and augmented reality combined.
Yeah.
That was the first use case, and we did that from 2013 was the first time I saw it. Yeah. And a former colleague of mine has developed an augmented reality app. It's called Gamma AR. He started it also in Aachen, then in Cologne, and now they are based in Luxembourg. So they also in a mainly French-speaking part, and they have developed this augmented reality app. It concentrates on the construction site, so one can visualize mainly through BIM 360, visualize all models, pinpoint the classes, comment in Gamma AR, and push the comments back to BIM 360. So it's a live per se augmented reality class detection solution. It's very, very cool. It's very cool.
It's exactly. Thank you very much, Padus, for this information. I mean, that's exactly so one of the use cases that you often see is the construction site for BIM data, right? So where you can see 3D models. It's also we use it. It's one of the use cases we're currently also further exploring with a large engineering firm in Zurich to visualize this BIM data for 3D buildings and other types of construction sites. So, but that's clearly one of the very logical use cases for this type of technology. And so our approach is a little bit different from most of the competitors, is since we integrate this GPS system in order to keep, so they can actually walk around a lot in these utility site construction sites without the data sort of drifting and moving. And but thank you very much, Pados. It's very interesting. I will have a look at the Gamma AR, see what they do.
Thank you. There was a second hand coming up, so please go ahead.
I think it was me. It's Frank speaking here from Heat Business too. I would like to come back to Regina's question, because you answered on that. Your system is not appropriately or properly working, let's say, in the building. Unfortunately, so in the InfraLab, it's already in the name, yeah, our infrastructure. If I put myself into the shoes of all of them, so I would say more than 90% is in the building, or let's say from our perspective is even meters below the ground. That means the use cases are cut it off here. And then my question is, so are there ideas how to get connection then, not using SIM cards or GPS perhaps, to use WLAN or the connection point from the customers, because otherwise it's not really of help. So how do you build the bridge then to make use cases for us serving and having our infrastructure under the ground or in the building?
And so if Frank, if I may, sorry, I hear.
Please mute your microphone if you're not speaking, Frank. Thank you.
So Frank, thank you very much. So the utilities that we work with, I mean, all the cables, right, they're underground, and that makes the solution very useful, because it allows a user to see what's underground while being above the ground, right? Now, I'm not sure. So you're talking about meters underground. Does it mean that the cables are in tunnels, or the pipes are in tunnels?
Yeah, our pipes are meters, even more than 30 meters under the ground. So the district heating pipes, yeah. So we are shipping hot water through them, and that's why I understood we will then lose connection, even being in a building. So being 5, 10, 30 meters under the ground, I can assume we will lose connection, or you will lose connection then.
Yeah. So to answer your question, yes, it's possible to use. We've worked a long time ago also with the ultra-wideband beacons. We can use Bluetooth beacons, Wi-Fi beacons to position, to understand the position of the headsets. That's not really a problem. It's just the technologies that are used for, like ultra-wideband and Wi-Fi and Bluetooth. They are not very to estimate the position of something based on those technologies is not. I mean, you will maybe, for example, with ultra-wideband, you get maximum 20 to 30 centimeter accuracy, and that was for the use cases that we currently have used our technology for not enough. So we had to go down to 10 centimeter accuracy, 5 to 10, and so for that we really need this GPS, because with the GPS we can measure up to 1-2 centimeters accuracy in the field where we are. Now, if this accuracy is not very needed, so for example, we're thinking about also there are a lot of tunnels in Switzerland, right? They go through mountains and train tunnels and things like that. So we are exploring also this area. However, it's not implemented yet. So if there's an interesting use case for heating at a distance, chauffage à distance, we call it in French, city heating, I believe, right? Where you would like to use different technologies to connect to the HoloLens. then I will be very interested, of course, to discuss this a little bit in more detail. But currently we haven't implemented that. I hope that answers your question.
Yeah, but very well. So I was thinking about, do you use then repeaters perhaps to get the signals out and in that accuracy? So that's perhaps, and what kind of then, and is that, what's the technology and what's the signal? Is that based on LoRa, Zigbee and so on? So how can we merge that? So what are the opportunities? I'm thinking in the opportunities to make the other 90% use cases for you, and perhaps not only thinking about 10% here.
Yeah. So the opportunities in this space, usually, for example, in buildings, what is used is buildings have a lot of Wi-Fi beacons all over, right? So that computers stay connected when you move around, and your phone stays connected, etc. To the Wi-Fi network. So you can use those beacons to estimate where you are, and that is, however, so I don't know if you have those in tunnels for an operator to be able to call, or if you have repeaters like that. So there might be already infrastructure in place. I can imagine, but I'm not sure. I'm not familiar with the underground tunnels for city heating. But you would have to have certain beacons along the tunnel so you can estimate at which beacon you're connected to and at what distance you are from that beacon. And that is so that you would need.
Okay, we have Regina again.
Yes, sorry, maybe I bother all the others, but yeah, I think we still have some measures to do on the ground. And we have one application when they try to get the data of the water meters. And when the people used the system, they realized that there was not everything accurately recorded if they had no signal. So how safe are the people in your case that everything is recorded, or even maybe immediately a backlog done, because otherwise you're banned to the device and to the paperwork. So can you say something about the malfunction of the system and how you can back up it? Because I think it's still, if it's reliable, for some cases, an appropriate technology if it works.
Yeah. Good question. So we are our current product is always connected to the internet. So what we do is you can store the data on the glasses themselves, but also send it to a server online through the internet. So to your own company server or to other cloud types of environments. So that means that you can easily create a backup of the data that was stored during an installation process. That is, I think, as much as I currently can say about the malfunctioning or the backup system you might have. Now, I think I think a big rollout will give me more information about what the options, how if we run into problems with customers, but for now we haven't seen any problems. I don't know if that gives enough information, but
yes.
Yeah, it's just we're connected to the internet, so we do the best we can to avoid having those problems, obviously. And also for the Deutsche Bahn, it's going to be the same problem. If we're not supplying this or storing this data online, and the headset, breaks down for whatever reason, then you have a problem, because then you have to go back to the paperwork.
Great. Are there more questions for Daima from this group? I guess that's not the case. Maybe then we can check those two other use cases you have in the videos there. Maybe we can see some more of the action from Relapse.
Yeah. So this is let me quickly, if you don't mind, I'll stop sharing my screen for a second.
Yeah.
Or yeah, hold on. So I wanted to quickly show, and I hope this will work, to give you an idea of to give you an idea of, for example, the Deutsche Bahn video. It's just it's a very recent video, and it's not a polished marketing video. If you if you say so, you see the raw stuff. I think that's even better. But so you have an idea, for example, what we can do with this guidance. It's in German. I hope I translated correctly everything. So if there may be some mistakes, well, maybe good for a joke. Or so here you see us. So what we're doing here is to give Deutsche Bahn an idea. Since we cannot travel with COVID, we had to sort of find a way to show how we install these balises on a railway track. So this is an abandoned railway track in France. And here you see the home screen of our solution. It's connected to the internet, it's connected to a GNSS receiver. I'm thinking now. Actually, I would like to share, is it possible maybe, Ben, to share this video at a later stage? Because I think maybe from a sort of a patent point of view, I would maybe have to wait a couple of weeks, 2 weeks or so.
Of course, sure.
Is that possible that you share it later with the participants?
This is possible, of course. Yeah, we will also upload this. I recorded this this session, and I will upload it to YouTube and use it for the InfraLab channel. So this is something I could add later on. So this is no problem. You can just send me some files or a link, and I can include it, and then can inform the participants that the video is there.
Okay,
Sure.
in that case, I would like to keep this video for a later moment. What you see here right now is not a problem, but what later on in the video is still under an NDA. So I would need to sort of, so I will keep this for now, if you don't mind. And my apologies to all the participants. Other videos that I can show, hold on, I will go back to my presentation. Those you will also see on the internet. So if you visit our site or website, you will find the same videos. So this is, for example, from, I hope you can see it, but does it need to be bigger? I can make it bigger. It's better. So here you see our first pilot that we did with the water company in the Netherlands called Evides Waterbedrijf, Wasserbetriebe. Arbeiten mit Augmented Reality. So what basically, there is a lot of construction going on in the city everywhere. And one of the major issues is that you can increase the efficiency by showing, for example, to the excavator, the person in the excavator, where the cables and pipes are located. So here the user is wearing the HoloLens, the HoloLens 1, and sees below through the, right, sees basically where the cables and pipes are located. This is a bit older version of our application. This was our first pilot, but at least gives you an idea. So we have sort of what's interesting here to see. I would like to show that here. Oh, that easy to share videos, unfortunately. this. So what you see here is we project information on the ground, so you can really see the, I would say, the horizontal projection of the underground grid. So here you see water, and here you see well, basically two water pipes, one larger, one smaller, and it follows. You see, it follows this trench that has been excavated. Now the idea was to use this in an excavator. However, you can imagine that the excavator roof will block the GPS signal. So this works if you're just standing still, but and if you know, don't turn too much with the excavator. But if you're driving around a lot, then you can lose accuracy. And in this case, so we are not currently, we're not using it really in the excavator anymore, because we need to guarantee this accuracy for our customers. I think that's the important message. Here you see the work we've done with Basel and Hofmann. It's a 2-minute video. I can do it with sound, I think. I hope you can hear it.
I cannot hear it.
Yeah, I think I have to check mark something that this sound from the video will go through. But I will explain myself a little bit. So this is with the engineering firm in Zurich, and what they wanted to see is what was underground, the BIM data of the underground. Now here you see, this is the old version as well, the old HoloLens. So here you see the 3D data. It's a bit strange maybe to see it through the video, but so this seems to be above ground, but it's actually underground, and that's a bit of a problem of overlaying virtual images over a video, because you cannot really, you don't have the same experience as using those glasses. But what you see here is the structure, the BIM data of the underground infrastructures that they placed in the street. So at least, but it gives you an idea of, so you see it sort of seems to move a little bit, but so here is this concrete, a concrete hole they made, and also here you see sort of a difference, but once you move on top, that's all caused by this sort of perspective from where you see it, but if you move on top, it's like neatly placed on top. Then, so that's for BIM data, but we also show here, for example, in Faficon, we show the underground infrastructure, so they can see where the cables and pipes were located in the street, the manholes, etc. And what was interesting is that it was very easy. They really picked it up easy on how to work with the solution. So you can also show here. You can show the metadata, the attributes of the information of the cables and pipes. What we noticed is also that there was data missing of a manhole somewhere. I don't think it's in the video, but you immediately see where the errors are in the data with respect to reality. So you can correct that in the field through those glasses immediately. I think that's about it. Sorry, I couldn't share the sound for now, but they're on our website. So please have a look on our website to see a bit more if you want more information on the videos.
Great, thanks, Thema. Thanks for giving us the sound for the video by yourself. You explained it really nice. Are there any more questions to Thema from this group? I see that is not the case. Otherwise, I would put this video on YouTube, and I would write a little blog entry for InfraLab website, and I would like to put your company details in there, Thema, as well. So if anybody has any more questions or want to contact Thema about the augmented reality or VLabs in general, I think it's fine to go ahead and contact him, I guess. Tell me if I'm wrong. But otherwise, I would, yeah, as we don't have the breakfast because it's digital, we cannot have a nice breakfast together now. But maybe you can grab a coffee and think about the presentation, think about the possibilities of augmented reality in the future. And thank you again very much, Daimar, for your presentation. Is there anything you would like to add?
I wanted to add just one thing. If people are interested in a pilot or demo, just please don't hesitate to contact me. Ben, since you're putting my details or the company details on your post, I can also hold on. You can contact me on. I'll put it in the chat.
Yeah.
.ch. So in the chat, you have my email. Please don't hesitate just to give me a call or send me an email and we can set up a call. And I'll be happy to discuss more in detail if you have any specific questions or needs for a pilot or a demo. I'd be happy to assist you. And thank you very much for your time. Sorry.
Thank you very much for your presentation, for your input. I think it was really interesting for the people here, and I really enjoyed it. I got all my questions answered. So yeah, I guess that's it for the first digital BizBreakfast of InfraLab. If you want to know more about InfraLab, you can check www.infralab.berlin, where you can find additional information and where you can also find a blog entry in the next days about VLabs and this BizBreakfast. And I hope to see you all again in the next event. And yeah, thank you very much, Daimar. Have a great day, and I wish you a lot of success in the future.
Thanks, Ben, for setting this up. Really appreciate it. Thank you.
Thank you very much.
Thank you.